Okay, this question is quite easy, so I'm going to attempt to explain it while eating a cheese sandwich. First one is really just understanding the notation for set theory. So we've got 5 different phrases here. Top we've got A is a subset of B, and then the reverse statement B is a subset of A. This one says that A union B covers everything. E for everything, the universal set. The second one says A intersection B equals nothing, 0 the empty set, or 0 with a line through it, like sort of Swedish O. And then this one says that A intersection B equals A. Now, okay, I didn't really explain the last 3 statements, so I'm just going to have another bite of the cheese sandwich. Very nice. Well, thanks for a £2 meal deal. And now I'm going to explain the last 3 statements. If A union B covers the universal set, then that means that everything, well, A union B means either A or B or both. So if A union B is everything, that means that everything in the group is either in A or in B or both. And you think, well, that's kind of obvious. But when you draw that box around your circles, that box is meant to pick up anything that's not in any of the circles. So you can have things which are neither A nor B, and they would go in the space outside the circles, but as part of the universal set E. So, for example, if the universal set was the class and Group A was people who played football and Group B was people who played basketball, you'd have some people who played just football, some people who played just basketball, some people who played both, and some people who played neither. And so that's the way the space would go. I think most people are happy with that. So the statement A union B equals everything basically means that there's nothing outside the groups. So that would be, I don't know, say you have to take a language at school, so Group A could be German, Group B could be French, and Group C could be Spanish, and everybody would have to be in A union B union C because there's nobody who would be outside that group. A intersection B is nothing. That's this statement here, the fourth statement. That means that the intersection corresponds to the things which belong to both rules. So it belongs to A and it belongs to B. So it's saying that there's nothing which belongs to A and B, i.e. A and B are completely separate. The final statement, A intersection B equals A, means that if you take the things which belong to A and B as well, that corresponds to the things which are in A. Now, that's a trickier statement to interpret, and it has come up before. If the overlap between A and B is A, then that means that everything in A must also be in B. I hope that makes sense. Anyway, let's see how it applies to this question. First one, you've got B inside A, which means that B is a subset of A. So quite clearly, that's the way we could define that. Let's just double check that doesn't apply to the other one. Third statement says A union B equals everything. Well, because you've got the box around A and B, it's not clear. You have to assume from the way they've drawn it that there are things which exist outside of A and B, so that's not true. Fourth statement, A intersection B equals nothing. Well, clearly there is some overlap between A and B. It's B. And the last statement, A intersection B equals A. Now this one is similar to this question, but slightly different. Cheese sandwich. Bit of celery in there for crunch. If A intersection B were equal to A, what that would mean is that we'd have a situation where it was the other way around. If A intersection B equals A, then that would mean that A was completely contained within B. Here, B is contained within A. So we could say that A intersection B equals B. But that's not actually one of the statements up above. But that is also true for this one. Now, the second one's slightly easier. Are A and B subsets of each other? Well, no, because A is inside B, B is inside A. In fact, A and B are completely separate. If A and B are separate, what that means is that there's no overlap. Therefore, A intersection B which is the group that corresponds to things which are in A and B, equals empty set. And that's that question done. And now I'm going to finish my sandwich.